Hello. This video we will be discussing exponential function. So what are exponential functions? Exponential functions are any function we can write in this form, in the form of a to power x. So f of x is equals to a to power x. But here we have that a has to be greater than 0 and a is not equals to 1. But our x is any real number. So it means x can belongs to any number between minus infinity to infinity. So here, let's discuss this one. Why do we have this condition? So when we say if you have a number line, this is a, no, this is 0. So it's saying that what our a can only belongs to numbers bigger than 0. Okay, so this is 0. So numbers, it means your a cannot be negative. So a has to be greater than 0. But if you come to 1, it has to be open because a cannot be 1. So it means you have two parts. It means a can be between 0 and 1, or a can be greater than 1. So now let's see this one. It means a cannot be less than 0, right? So let's see why a cannot be less than 0. Let's assume, if we assume that a is less than 0, so what does that mean? It means our function f of x is just what? A, right, to power x, right? So for example, we take a to be what? It means that if you find, for example, take a to be, take any number less than 0. Let's say you take minus 1. So let's have a function like this. But now remember here, x is in what? In R. So if you have this function now, because x can be any number in R, you will see that if you try to find, let's say, f of half is going to be minus 1 to power half, which is going to be square root of minus 1, which becomes a complex number, right? And we don't want to have this situation. So it means that a cannot be less than 0, all right? Now, let's see why a cannot be 0. Now, let's assume a is 0. If a is 0, it means the function f of x will be just what? Will just be 0 to power x, where x is in R. And here, for example, now, you see there will be a problem because x can be any R. So, for example, if you take x to be, let's say, even minus 1, if you want to find f of minus 1, it's going to be 0 minus 1, right? Which is going to be 1 over 0, which is undefined. So you see that is why we remove the 0. A cannot be 0. Also, a cannot be less than 0, right? So what next? Then we also need to consider this one. Why a cannot be 1? Because when you say a is not, a has to be greater than 0, it means you want to exclude a less than 0 and a equals to 0. And this is just explanation why you need to exclude it. Because if you don't exclude a less than 0, you can have complex number. Here, if you take a to be 0, you can have it to be undefined. Now, let's see. Let's assume now a is equals to 1. If you assume a is equals to 1, it means our function f of x is just going to be 1 to power x. And this is for any x in R. So this will just be a constant. It means for any x in R, 1 to power x is still 1. This is going to be always 1, always. And that means the function is going to be what's a constant function. So you are going to have a constant function. So it's no longer an exponential function. So that is why a cannot also be 1. All right, so example 1 is just simple evaluation. You have f of x is this. So we want to evaluate this. It means you want to evaluate f of x at 3. So f of x is 4x. It means f of 3 is just 4 to power 3. And that means that f of 3 is going to be what? 64. Then we can also find f of what? Minus 2. F of minus 2 is just going to be what? It's just going to be 4 to power minus 2, which is 1 over 4 to power 2, which is just 1 over 16. Then finally, we can find f of when x is pi. Remember, f of x is still the same. It's still 4 to power x. 4 to power x. Then we can find f of pi. It's just going to be 4 to power what? Power pi. And here we can leave it just like this. Now, example 2. Example 2, we have f of x is equals to a to power x. F of minus 2 is 1 over 3. We want to find f of 6. So what we can do is we can use this information to find what is a. So we are given that f of x is equals to ax. And we're told that f of what? Minus half is equals to 1 over 3. So what is f of minus half? F of minus 2. So what is f of minus 2? Using this function, this will just be a to power minus 2. And this is going to be 1 over 3. So here we can write it as 1 over a squared is equals to 1 over 3. And this simply means that a squared is equals to 3. So a is going to be plus minus root of 3, right? So with this, we have to take the positive 1 because a is our base, right? This is the base, and the x is the exponent. So it means that a is going to be root of 3 because we know that the base is always greater than 0. Now, to find f of what? F of 6. F of 6, you just need to go into the function and replace what? We know what is a now. A is root 3. What I'm doing is this. Remember, f of x is what? We can write our f of x now since we know a. F of x is now root 3 all to power x. Then we can find f of 6, which is just root 3 all to power 6, which is 3 to power half all to power 6. And this is 3. This is to power 3. And this will give you what? 27. All right. For this one, we have f of x is equals to a to power x. F of 3 is 27. F of minus 1 plus f of 0 is what we are looking for. So we have f of x is equals to ax. F of 3 is equals to 27 we are given. But what is f of 3? It's just going to be a to power 3 is equals to 27. Then a is what? The cube root of 27. And that will give us a is equals to what? A is equals to 3. So what it means is that our f of x is nothing but 3 to power x. So therefore, we can find f of minus 1 will just be 3 to power minus 1, which is 1 over 3. And we're looking for f of minus 1 plus this. And also f of what? 0 is 3 to power 0, which will give us 1. So if you come back here, f of minus 1 is basically what? F of minus 1 is 1 over 3 plus f of 0, which is 1. So this will give us 4 over 3. All right. So now let's see more of these exercises. I think we have some in my notes. Okay. Let's take this question. It's similar. All right. So let's answer question number 4 in these exercises. Question number 4. Where is the question number 4? Yes. So we said f of x is 3 to power k minus x, and f of minus 3 is equals to 3. We want to find f of what? F of 2. So what we do, the same story here, we can just use the fact that, let me write it here, f of x is 3 to power k minus x. And that simply means that that we can find what is f of minus 3. F of minus 3 is equals to 3, right? Or we can write this first. What is f of minus 3? This will be 3k minus 3, right? So it means this is 3k plus 3. But we know that f of minus 3 is equals to 3. But this is f of minus 3. So this will be 3 to power k plus 3 is equals to 3. And we have, this is an exponential equation. We can solve this easily. Here is to power 1. We can drop the base. So we have just k plus 3 equals to 1. So k is equals to 2. Now, k is equals to 2. What does that mean? It means our function f of x is just going to be 3. K is equals to 2. So it's going to be 2 minus x. 2 minus x. All right. K here, no, not 2, is minus 2. Sorry. Minus 2 because you have 1 minus 3. So the equation here is going to be minus 2 minus x. So now we can find f of 2, which would just be 3 minus 2 minus 2, right? So this will be 3 to power minus 4, which is 1 over 3 to power 4, which is just 1 over 81. And now this is the solution to number 4, exercise 4. All right, so I think that will be it for now. The next video will be about the graphs of exponential functions. Thank you for watching.